consider this product. X plus 5 times x plus 4. If we use the box method, to multiply this out, I would write here x plus 5 and x plus 4. Right? Now, I know you know how to fill in this boxes, all the boxes in the box here. So we would have x squared, 5x, 4x, and 20. The point is that the product of these two binomials would be, what would be my answer? What would be my trinomial? It would be x squared. Here I have, that's 9x, and this is 20. All right. Something that, we have all the terms here that give us this trinomial. What matters to me is that you're able to see where each of these components, where they came from the box. The easiest one to identify is, where will this first term come from always? From the first box. The first term right here is going to come from this box. And where will the last term, where will this one, where will that one come from?
The last box.
The last box. Those are the easy ones to place in the box. The one that's tricky, right, is to, I see x times x is x squared, 5 times 4 is 20, I get that. The one that's tricky to see is, where is the 9 coming from? I don't see a 9 anywhere in here. Well, that's going to be from these two boxes here. And this is what I want you to, a property about multiplication tables that I never showed you last week. I'd like to show you right now. Give me 4 numbers, please.
4.
1, 2, 3, 4. It doesn't matter. You can give me any numbers, you positive, negative, we can try fractions or decimals. The point is that when you multiply this out, 2 times 3 is 6, 2 times 4 is 8, 3 times 1 is 3, and 1 times 4 is 4. When you multiply these two numbers, you will always get the same as the product.
Witchcraft.
Now, a very simple explanation. What you get when you multiply the diagonals of a multiplication table like this one, it's no mystery. What you're going to get right here, what numbers did you multiply to get the 6?
2 and 3.
This one and this one. So here we have 2 times 3. What numbers did you use for this one? So when you multiply these two numbers, you're really multiplying 1 times 2 times 3 times 4. All 4 numbers that were here, right? Where did these numbers come from? 2 times 4 and this one? So when you multiply these two numbers, what numbers are you really multiplying? 1, 2, 3, 4. All the numbers that are here. Where did the 168 come from? 4 times 2 times 7 times 3. You multiply all 4 right here and all 4 right here. Always the same product. Check this out. What is 20 times x squared? What is 4x times 5x? It works with polynomials as well. We need to know this property for the following reason. When you have a trinomial like this one, now you want to write this down. When you have a trinomial like this, and you want to factor it, this is the process that you're going to go through. You're going to say, I'm going to need my first term right here. This is going to be the x squared. My last term, where's it going to go? In the last box. Does that make sense?
Yeah.
And here's where the x game comes in. Where's the 9 going to go? The 9 is going to go in these two boxes. We need it. But the question is, how are we going to split in the 9x? Is it going to be 1x plus 8x? Or 2x plus 7x? Or 3x plus 6x? So what we want to figure out is, what is the right combination of numbers that we want right here? And here's how we find it. Hold on one second. The way we find it is as follows. We need two numbers that when we write them down, and I multiply them together, they have to give me the same as the product of these two numbers. Now you can forget the x's. Don't worry about the x's. We care about the 9. We know we need x's here. So what's 20 times 1? 20. Let's just forget just the numbers. 20 times 1 is 20. I need two numbers that multiply together give me 20. Because these two numbers multiply together give me 20. And added together, when I add them up, they have to add up to the number in here, which is 9. Now you have an X game. If you can solve this X game, then you can fill in the box. And it's going to be a piece of cake to figure this out. Now we know what the numbers are because we have them over here. 5 times 4. 5 times 4 is 20. 5 plus 4 is 9. Does that make sense?
Yes.
Now, it doesn't matter where you write the 5 and the 4. You're going to write one in each box. And here's how you finish the process. Once you have your box filled out, the factoring process is completed by factoring the GCF in every column and every row. What do these guys have in common?
X.
We write an X right here. What do these guys have in common?
4.
A 4. It's a plus 4, so you have to write out a sign, so it's plus 4. What do these guys have in common?
X.
And these guys here? And that's how we get X plus 4 times X plus 5. Now, we already knew what the answer was, so let's do one where we don't know what the answer is. Arranged right here in some combination. The proper combination has to meet this requirement. Just remember, forget the x's. Don't worry about the x's. The x's go there. They have to add up to 8x. So here's what we say. 15 times 1 is what? I need the product of the numbers that I'm looking for to be 15. And what do they need to add up to?
8.
To the 8 that I'm missing.
3 and 5.
So you try that, and very quickly you're going to find that those numbers are what? 5 and 3. Or 3 times 5. Because of time, I'm not letting you just play with the numbers right now. But so there it is. What are we going to have right here? 5 and here?
3.
And 3. Question?